All right. So back in at my soldering here. Got a bunch of components that I am going to solder together. So part of it is these LED rings. Got some more speakers. I'm going to put together, and then also got some more of these audio DACs. So just those little audio amplifiers. So let me just go ahead and open these up. And I'm going to start soldering them together like the other ones that I've got. And I am still waiting on more of these microcontrollers, but at least this will let me start putting some of them together. I am still waiting on the power supply stuff, which in this case composes of the Boost 1000, LiPo charger, and power boost. Which a lot of this stuff does run on, can run on 3.3 volts, but I have found that the speaker does take quite a bit of power, so it does not act super great if we don't have that 5 volts. So let's see, let me get some of this organized. We've got a bunch of push buttons, got a bunch of microphones. I've got these LED wires, which we will do something with here today as well. And let's see. Still haven't figured out how to do chat on here. So that is going to be my standard. So what I'm going to do is separate out these two. Let's see, okay. Let's see. A straight wire there. All right. So we're going to go. Let's see. Looks like not all the wires got caught up in here. Don't want that too cause a problem later. So yeah, let me get these positions so I can use my PCB vise. There's that guy there. So I'm going to do power and ground first. Let's go ahead and tack that. All right. Power and ground, and then the rest of these wires all just go in one by one. Just like that. Just go there. Yep, looks pretty good. These are pretty easy to put together because all of these connections just line right up. There, this guy. Just have 4 more to go. So let me get this prepped. Splitting off that 2. All right. Power and ground. Let's see if we can get all of these. Nope, nope. It's getting a little ambitious. All right, let's go. These 2 first. Tack that in place. I can do a better job than that. There we go. Get that soldered nice and neat. There we go. All Now get the other 3 wires. That one. Ooh, that one's being a little tricky. There we go. All right. That one's set. Let's get these 3. 1, 2. And get that one a little bit more. Make sure I got good solder joints here. There we go. Trim off those leads. So the next one. I'm going to try this a little different. This time I'm going to go for the other side first. Those 3 holes first. All right. There we go. Got 3 connectors. Yeah, connect power and ground. Actually, that was a lot easier. Problem with this is I gotta split the wire and skip over 2 connectors. To go in. Yep. With the cables bent like this, it does put a bit of tension. So if I don't hold it in place while it's cooling down, it does kind of pull that wire out of the through hole. And I'm worried that it might result in a cold solder joint. All right, 2 more to go. at the end. These are very small wires. Just want to make sure they're all going in. There we go. All right. Perfect. Now let's solder that in. Yep, that looks good. Trim the ends off. And then put power and ground. And here. This one I am going to need to hold it. It's that wire at the very end that is just real tricky. Keeps wanting to pull out. Yeah. Oops. Okay. All right. Let's try this again. There we go. And one more speaker. All right. That one. There. I do love this ribbon cable for doing wire organizing, but sometimes it can be a little bit of a pain getting all of these connected. But it is very worth it when it comes to cable management. And getting closer to what I want this to ultimately look like when it goes to manufacturing. It does really make it look so much better with the wiring inside. All right. Those are all of those speakers. Let's see. So I have 1, 2, 3 of, yeah, 3 of these. So I'm actually going to finish up 2 of these speakers by adding these to it. I take some 2 connector wire. Let's measure how long these are up to there. I'm not doing enough to justify spinning up that pot of solder, so I am just going to do this the old-fashioned way. And just tin these wires with the soldering iron. Ah, my husband is on the chat. I guess we figured out how to do it. So how did you get in the chat? That it required like a subscription or something before. Ah, okay. So the mobile app worked. Well, and today I am soldering together some new amplifiers and LEDs to continue making some smart speakers. Another thing that I did earlier today was set up some a new custom component for Home Assistant that handles different medications and supplements so that you can keep track of them in Home Assistant. And it is currently tracking the name along with the status, if you've taken them or not, if you forgot it, or if you're going to take them later. Which that's all going to be used in the medication reminders for this particular application of smart speaker device. Um, Previously, all of that stuff I was using the helper components in Home Assistant, but um, that does use a really nice user interface to do it all. Um, but it is a bit time consuming to do a whole bunch of medications and stuff, and there's a lot of process that you got to go through, a bunch of hoops you got to jump through to get it all set up. And so creating a custom entity makes it a lot easier to manage that. Let's see, that wire is not cooperating. I think I need to strip these a little bit more. Good. All right, let's try that again. I want these wires to go through that through hole nice and clean. There we go. And then the other end just gets soldered to these 3-amp speakers. That looks good. Get the other one here. All right, I'm gonna get these wires in there, and then I will say a few things about the speakers that I'm using. All right. Yay. Okay. So these are the speakers that I'm using. They connect right up to the amplifiers. These are 4 ohm and 3 watt speakers. They run anywhere from like 3 volts to 5 volts, and they utilize 3 watts. It is a pretty decent, like, full range for this size speaker. It is a little large for comparison. This is a different 3 watt speaker that is a little smaller, but it just doesn't give quite the sound quality that this one gives. Um, these are good for like a lot of applications where you're going to be closer to the sound, or you don't really need a loud sound. But for this, especially for voice, this speaker will definitely get your attention. Um, It is a little tricky because with these speakers, it is not quite like so. If you just hook up wires to this, you are going to be able to hear sound. But where you get really good sound is what you attach this to. So having a box um, that goes on the back of this does help to amplify the range of sound that you get to this. Um, that's why it is really important. Like I've gone through a bunch of different iterations with designing these devices, um, enclosures, in order to get the most audio amplification out of this through the acoustics. Um, I don't really know all the terminology for that, but um, yeah. Anyways, speaker design is a lot more than just sourcing the right electronics. There is some like physical structure that you want to add into it, which does add some complications depending on what you are going to do and form factor and things like that. So let's see, rearrange this stuff a little bit. I have this speaker, which I'm going to attach to this guy, and then that will give me 3 of these speakers. All right. I don't need the extra tabs on the edge of these. I like these speakers too because they do mark them as the positive and negative side. It's not as important for the application that I'm using, but you know, I generally, if polarity is marked, I do like to stick with that polarity. All right, separate out these guys. And get my positive wire on the positive side. I get one of the ledges there so I can actually push up against something. There we go. Positive. And negative. So there is a full speaker and amplifier connection. All right. Once again, we're going to go positive. And negative. There we go. There's another speaker. And this one I'm just going to attach to here. White stripe positive. No stripe negative. It's got a little flare at the end. All remember when I first started using silicon wire, I noticed there was a lot of complaints that people had with the wire being just very flexible, like wet spaghetti. And I looked at that, and people that were saying that was a thing they weren't looking for, and I was like, oh my God, for doing wearable stuff, I would love to have wire that acted like spaghetti, that was that flexible, and I was not disappointed. I understand why some people don't like it. It does make some things a little more difficult to do than the vinyl wire does, but I tell you, once you get used to it, I don't think I ever want to go back to doing vinyl wire. All right, there we go. Yep, that's all set up. So this board is almost complete. Let's see. Do you want to do any other ones? I might as well, while I'm here, connect these other two speakers. So I'm not going to connect all speakers up to these because there are a couple of other applications that I'm going to be doing that may require a different speaker or a different length for the speaker wire. There we go. Okay. Had some big tapered ends on those two. They're making it harder to get things in. There we go. Okay. Solder those in place. All right. Set those. All right. Okay. That is sometimes the problem with doing the bulk wire tinning is some of the ends end up getting flared out a little bit. Not too big a deal though. All right. got those. And we have two more speaker amplifiers. So I'm gonna put these back into the Class D 3-watt amplifier audio deck things. All right. So these components, I am starting to run out of room on my thing. Let's see. I think I'm going to put them. I'll put those over there for now and start into my NeoPixel rings. So let's see. So these aren't official NeoPixel rings. These are some that are basically the same form factor. Looks like, yeah, they pretty much went right off of the design for the NeoPixel rings. You do want to test them out though. So my standard for these is white is going to be power. Center is signal. And the edge is ground. So this one is marked for DI, which I'm going to assume is going to be data in. And I'm going to do this from this side. Go. All right. Power 5 volt. When it comes to these types of addressable LEDs, 5 volts is something these can run on, but I typically have no problem running them on 3.3 volts. It really just depends on what your microcontroller logic is running off of. But typically, I do try and keep that at 3.3 volts because I don't need them super bright. In fact, I usually have to turn them down because they are usually way too bright. And then we have ground. On the other side here. All right. Pull that through the center. These just laying between the LEDs. And now what I'm going to do is grab one of my testers. Let me double check if any of these do the thing. So you're going to get a battery. Battery. I don't know that this one's going to work, but we will find out. Use this. There we go. Okay. So this is one of the microcontrollers for LED driver that I made a long time ago, and comes in real handy for this kind of thing where I just want to test to see if these pixels are working. Put a connector on here. Try these guys. Yeah. No. Oh no. That's. There we go. These are some JST connectors that I like to use for the LED connectors. So I'm going to do the center. That way down. And I don't need to get this like really super connected. I just want to make sure I'm testing these. There we go. Make sure none of those are going to touch each other. There we go. All right. So now let's plug that in. Yeah. All right. Well, that ground wire wasn't really well connected. Yeah. All right. Oh, perfect. Let it cycle through all the colors. Make sure all the colors are working. Yep. Looks like red, blue, green, all working, and they are all addressing as I would expect. Typically, the only thing that I find with these that might need to be changed is occasionally the blue and green channels on those LEDs are mixed up, but there is a bunch of stuff that you can put in the coating that will let you change those up is as to what order the red, green, and blue LEDs are in. So that's great. Looks like I got a good new source for getting a bunch of the RGB LED rings. Those were not too bad a price as well. Especially for this low run, but ultimately I'll probably still just order from World Semi. All right, data in. Oh, coming from the other side. So with these types of LEDs, there is a signal out, or there's a signal in pin, and then there is also a signal out pin. And basically you want the signal wire to go in to the signal in, and the closest LED to that is going to be our address 0, and then every LED that goes out from that first one connects to the next one and the next one and the next one, and just keeps going up until you run out of LEDs. So if I wanted to connect 2 of these rings together, I would do data in here, and then data out here, and then data into the next ring or string. It could be any form factor as long as it's the same LED type. Then you can run those addresses into any form factor that you want. All right, we got power in here. There we go. Actually, I think this should be perfect timing because I have another one of these devices that I ran out of NeoPixel rings for. So I am going to set up another smart speaker and have that as my little smart speaker at home again. Unfortunately, with the latest update to Home Assistant, something changed when it came to the text to speech option. It is looking like that is on the side of the core Home Assistant process and not anything related to ESP32 or ESP Home or or even the voice assistant thing pipeline. But it looks like people are starting to get closer. There's a couple of like hack fixes, but I am kind of waiting to see if they can fix the core root of it. It's not a really big error, but basically what ends up happening is previously when you did text to speech, you would send it some text and then it would use the voice model to um, convert that text into one of the different speech models that they had and essentially do a MP3 or WAV file and then send that MP3 or WAV file to a media player that was identified on Home Assistant. And that's basically how the announcements worked for this particular project. And it worked actually really well because with that I could do automations and basically I could do a bunch of different scenarios to detect in an automation. A lot of it was schedule based to send those reminders of taking medications. But so previously, what would happen with that is that it would send the audio file, it would play the audio file, and then after it played the spoken text to speech file, it would stop the media player and the media player would go back to idle. But for some reason, when it plays the text to speech audio file, it does not stop the media player when it's done. And after the timeout session, it just plays that same text to speech audio over again. It just does it in a loop. I know that that is where the problem lies because I was able to test it with an edit to my firmware that basically would wait about 10 seconds after the text-to-speech audio would play, and then it would stop the media player. And that worked perfect. It would play the audio, and then it would stop it. But the problem is, if the audio was over 10 seconds, then it would just cut the audio off because it didn't know what it was saying. It didn't know how long the audio was going to play, which is kind of made it really handy that it had that feature that would automatically stop it after playing. There was a way that a few people had pointed out where I could use a method of detecting when the audio text-to-speech streaming was done with. but I had to change a bunch of the firmware code in a way where it was not using the streaming audio super efficiently. And so I ended up with a lot of caching errors, which I did not love. And it made it very glitchy. And then more importantly, it made it so it would do an announcement. And sometimes that announcement would just lock up the whole system. And I'd have to do this series of like reboot and refresh and all kinds of stuff just to get it working again, which is real frustrating because, as you can see with some of the videos that I've been doing before that update, I've had zero problem with doing back and forth conversation with this setup. So I am really hoping that they get that resolved so that I can continue using stuff, because they have some very nice updates that I do want to be able to use for the Google or for the voice assistant process. I am pretty confident that someone is going to have a fix. Ideally, that is one where I get to use the official announce feature that I'm supposed to have for the voice assistant, which is really the core thing that makes all of this possible. Because I'm not looking just to have a voice assistant, I'm looking to have a voice assistant that I can push out scheduled or triggered text to speech, which is really what is going to make this useful. It is a nice, fun project to have the speaker where you can use the wake word and you can have back and forth conversation stuff. But I do have a specific use case, which I think is, it comes in real handy in my house. And I really do think a lot of other people are going to find this very useful as well. Once I get all the documentation up and let people build this for themselves. Alright, so go there. I do want that to be on that side. So yeah, the stage that I'm in with this particular project is where I have done a bunch of breadboarding and tested out a bunch of different boards, got basic programming code going. And now I'm on to a stage where I'm building this according to a bunch of documentation that I have and notes for myself on how I built the other two. And now this is the test to follow those instructions to build more and see how good those instructions are. And if there's anything I need to add. Let's see. Come on, stay in there. There we go. And that's important to me because if any of you want to build these, those instructions are the ones that you're going to be using. This one is ground. It's going to go in that one. All right. There we go. All right. LEDs. All soldered together. All right. So those are all my LEDs soldered together. Let's see. Still waiting on some other components for the power cores. I think this is about all the quick stuff that I have to do now. So I'm going to go do a bit of programming stuff. And I will come back at some point, probably next week, to start soldering all of these together. I will have 3 more of these, so I might sometime in between then get some of these going, but yeah, I think the next big video I'm going to have will have me assembling with all these parts some of the tech cores for this project, and then probably talk a little bit about what the other parts of the infrastructure are in here. So, all right. Hope you all have a good weekend, and talk to you later.